This little project is an aluminium turbine housing that I'm doing some work on for a friend. The first job I did was making a aluminium tube for the input and milling a pocket in the body of the turbine housing and having this tube welded in. This little project has already started by a friend who wants to replace this very heavy cast iron turbine housing that he's going to put on this little turbocharger for a project he's working on. The idea is to replace it with this aluminium one, which he's already roughed out. I took it over just to do a few little jobs, one of which was to make this pipe and then install it into the housing. So there was some small changes made to the angle it went in, just so that it was centered on the scroll here. You can see it's coming out pretty good. You see right through. There's hardly any difference between the housing and the pipe itself. And not only was there a bit of an angle that way, there is obviously an angle this way as well. So this large lump of aluminium, which this is bolted to, is purely so this can be mounted in a rotary, an indexing head that can be pivoted. So it was mounted in the indexing head, and then it was rotated to get it just right, and of course transition left and right, X and Y axis, and then the whole head was tilted, and then this housing was bored out. This tube was manufactured so that it was a good fit, and then I got my mate Kevin to weld it into place. So this piece is attached to this again after we welded it, so I can just clean up this surface just to make sure that it's absolutely flat. I just got to chuck it in the lathe and take a very small cut. Now, once that's done, I'm going to use this piece of aluminium to make a replacement for this. I've changed the design a little bit for Rob, and this piece of aluminium will be removed. This will be modified so that this housing can be bolted to it on this face. And the reason we're doing that is because we're going to remove metal from this area around here to basically just lighten it. There's going to be only 10 millimeters left between this surface, which ramps up from here to this point here. So there'll only be 10 mil thickness down here, and I'll do it in 45-degree steps around here on this rotary table. Yeah, so anyway, this is going to be spun between centers to get this end and that end completely parallel. No real requirement, but just doing it because I've been told that's really the better way to do it by Kev. So I'll do it, and then this face will, or one of the faces will be machined off to mount this into it, and then this will be, and there'll be a groove cut at this end, which will allow the finger clamps to go in, clamping it down onto this table once it's on my mill. The problem is I don't have nuts, T-nuts for this, so this is the slots in the table, and this is a bit of steel which Kev's cut up for me, and I'm going to make 4 T nuts to go in here, and then I'll just drill and tap them to take the finger clamp hardware that I bought for the mill. So yeah, it just needs 4 nuts made. So a little bit of work to do. Probably going to start with making sure this is flat, remove that from the lathe, put this in the lathe, machine off both ends between the centers, and just carry on with progress there. I will add a couple of photos at the end of the video just to show progress with this. I only took photos, I haven't made a video, so you can see how it all fits together. It's pretty obvious and pretty straightforward, but you know, I'm quite pleased how it came out. It was a perfect fit, so really quite pleasing. And might make more video, or might take more photos as we go with machining this. I've just spun up one end of this block of aluminium and turned down, as you can see, most of the body, leaving just a bit that was clamped in the jaws. Now I've just put it in a 3-jaw chuck, given it a couple of taps with a hammer, and got the run out pretty good. It's not moving enough to worry about. So I'm still going to go with mounting up between centers. So I just got to machine this end down, face off the end here, and put a center hole in it, and we'll see how it goes. Alright, so this is the billet. I've now turned the outside diameter down, so it's clean and easy to run a dial indicator over, and I've also faced off the end. This end here was actually quite badly pitted, and you can still see there's still marks where the corrosion was, but it's the surface is well good enough. So this end has a center drill put in it, which matches the taper on the center. The other end, which I've already done, has a countersink in it, because the center that's going to go on the chuck, which this end will mount on, is 90 degrees rather than this one, which is 60 degrees. So trying to mount it between the centers and see how it looks. It should be pretty close. The center I'm going to put in the chuck end. I'll have to change the jaws around, but the center I'm going to put in the chuck end, I might just after I've mounted it, just take just a fine whisker of a cut to make sure that it's running the points actually centered and not describing a little circle, you know, because the jaws on this chuck are probably not exactly the same as the jaws on the chuck it was used on last, so it won't hurt just to clean it up. All right, here's the part mounted between the centers. I did clean up this center here, which means that it's very close to pressing on the flat surface of this piece which goes in the chuck. It doesn't, it's on the taper in the center, which is inside the end of this. So that it seems to be running pretty true, and this end is just the live center, which I've got jammed in pretty tight. I'll just start it up, you'll be able to see. I haven't taken any cuts yet, but yeah, so it's running pretty true. So I've got it set up. I'm going to machine this end using a boring bar, but of course the tip's on the wrong side for this end, so I'll just have to use one of the normal cutting tool to do that. I'll just get in as close as I can to the jaws without causing a big crash, and I might take a skim off the outside just to see how it's running, not because it needs it. In fact, I think it's actually good enough to use as it is. I'm just going through the process of spinning it between centers because that's what was recommended, and it is why introduce errors when you can be as accurate as possible. Anyway, we'll see how it goes. I've looked at how this will all stack up on the mill. So we've got the rotary table on top of the mill, and then we've got the adapter I've made, well, but partly fabricated, and then the piece on top. Now that, with the column up, not even as far as it can go, but up a fair distance, does leave room for the chuck and the various bits. It's just higher than I think I need. I'm not sure how cutting this is going to work, so I want to have the column down as far as possible for the best rigidity. And to that end, I'm going to reduce the height of this to about 35 millimeters, allowing for a band cut into it where I can put the finger clamps to attach it to the table, and just room for mounting this on and things like that. So that's my little project for this afternoon, is cutting this down to size, cutting the slots for the finger clamps, and threads for the mounting bolt, and all sorts of other things. So we'll show you when I'm finished what it looks like. The T-nut has been roughed out. There is a final cut just to bring this side down to height, just 0.1 to 0.2, something like that. Just a small adjustment just to bring it down. So yep, we'll be using the VFD set to 60 Hertz. So the motor's rated at that, though of course without the VFD it had been running at 50 Hertz here in New Zealand. So anyway, it's running at 60 Hertz, and on top of that I've set it to 2, which is the highest speed. So it's only a high-speed steel cutter, but it seems to be doing all right. The mild, I don't know if it's mild steel, the tool, the steel the nut's being made out of is reasonable quality, I think. So, but it cuts all right. Got a little hint of roke hole cutting compound here. So let's give this final cut a go. Right, so I've finished shaping the piece of steel for the T-nuts in the mill. While I was in the mill, I also went ahead and marked where the cuts are to be made, and also the centers for the holes. So I'm quite pleased with how it came out. It's a very good fit in the rotary table, which is nice. It is a little bit below the surface here, even when you lift it right up. So that's okay, although I might just take a whisker off the top once I've drilled it. Well, maybe not. We'll see how it goes. So what I've done with the marking is I've allowed 2 millimeters for each cut, and also just to clean it up. It might not be enough, but if I do the same at each end of each nut, it shouldn't be a problem. It's not going to be a problem anyway. Each nut's basically 25 millimeters long. That's what I've allowed. And there's going to be 5 of them plus a bit left on the end. So allowing for stuff up. So I should have this end up with a spare. See how it goes. After marking it out and drilling and tapping the holes, I took the piece to make Kevin's place and just sawed it up into the individual bolts. This last one I couldn't hold in the saw. It's just there's too big a gap between the edge of the holder and the actual blade. So Anyway, there's a little bit of finishing off to do. You can just see it on the bottom edge here, but I just do that with a file. I was thinking about running it through the mill again, but it's more work than necessary. So the idea is these go in here, and then just use a normal. I'll only be able to use the small finger clamps from the set I've got for the mill, as they are the only ones short enough to actually go in here without extending over the back of the rotary table. But 2 should be sufficient. It'll give me plenty of ease knocking it into concentricity on the mill, on the rotary table. And then once that's all clamped in place, I'll put this on, and I'll get this running concentric as well. Really don't need to get this concentric, but I will, just because that'll put this the bolt hole here right smack in the middle of where this needs to go. So yeah, making good progress. Alright, I have the adapter mounted on the rotary table now, using the smallest finger clamps I've got, and as you can see, it only just makes it. So thank goodness I didn't have to make new finger clamps. I have centered this up, although there's no real requirement to. It's the piece that goes on it that needs to be centered. But as you can see, it is pretty good. So it's a good place to start. The bolt's going to be right in the middle of the piece that's being machined when I am rotating this, or when it's all centered up. So that's ideal. Next step, fit and clamp into position the piece to be machined. Right, I've got it all set up, ready to make some cuts. Now, there's actually a bit more to it than what I thought. As I went along, I sort of came across other things that I needed to set up. So where it is at the moment, I've got it set to 0, give or take, on the rotary table. At the moment, it's not exactly there, but it doesn't matter. And one of the things I had to make sure I got right was that the center of the cut on the y-axis, or the x-axis, I've chose the y-axis, so the x-axis is centered on the actual bit that's been having bits cut off it. Now the reason for that is, as I increase the depth, and I want it to go perpendicular, not at some odd angle, which it would if I had it not centralized. So there's that. So that's been set up quite precisely using the dial indicator and some feeler gauges and a rod and yada yada yada. Anyway, it's within a very small amount. And then this piece also had to be rotated so that the start 0 point, if you like, was lined up for the start of the cut when this was 0. So that's where that is. And then on top of that, had to get it concentric, which it's not perfect, but it's pretty good. Certainly good enough for this little job anyway. So yeah. So time to start making some cuts, taking some metal off it. I've just marked off the depth of the cuts using felt tip, just to give me some idea while I'm doing the work. Of course, the actual depth of cuts, etc., will be done using the z-axis. So shouldn't be a problem. It'll be certainly close enough and repeatable. Yeah, so these axes, so this is the y-axis, they're 0.01 millimeter per graduation, so it's easy enough to, there's a bit of, in fact, quite a bit of free play in it, but if you're always moving it in the same direction, it's very easy to get the accuracy. I mean, the graduations are 0.01, you can easily get some part way through that, so, you know, at least 0.01 0.005 millimeter accuracy with these if you're very careful with what you're doing. So I have pretty good faith that this is going to come out. The first outside cut has been made from 0 through 270 degrees to a depth of approximately 6.5 millimeter. The second cut inside has been started and is currently at about 2 millimeters, and there's a third cut to be made as well to take it down to 6.5 for the full 270. And then starting at the 45 degree mark, it'll be taken down another 2, and then at 90 degree it'll be taken down another 2, and so on. The machining in the mill has been finished, just needs a little bit of deburring the edges, things like that. So you can see how I decided to do it. There's a number of steps. Every 45 degrees there's a step of approximately 2 millimeters. It varies depending on the depth of the scroll on the other side, on the inside of the housing. So it's come out pretty good, quite happy with it. There's a little dent in the top right corner there, you can see, which was a mistake made early on, but the rest of it came out pretty good, quite happy with it. So just be a matter of getting it off, sorting out the edges and giving it a clean. The finished part came out pretty much as I expected, and I'm quite happy with the result. The last thing to do is to make an adapter between this piece and the center housing on the turbo.